Okay, so what I put up here, as we talk here, you can talk about logical arguments, is I put up an example of a logical argument. A logical argument is, like I said, something like this, where you have a couple of statements and then a conclusion based off of those statements. This one has two. I think most of the ones that we work here at first are going to have two statements to begin with and then a conclusion. You can have more than two up here and before your conclusion. But this is a good example. May have heard something before, seen this before, but this is what a logical argument looks like. Now, the parts of a logical argument, all right, so the statements before the conclusion, so obviously this is our conclusion. That's probably fairly obvious. The other two parts, in this case, I've got two what are called premises. So the statements before your conclusion, those are your premises of your argument. So this we would maybe call it premise one. This would be premise two. I won't number them off like that, but just to know there I have two premises and then I have a conclusion. So that is how an argument, logical argument, is arranged. You have some premises, then you have hopefully a valid conclusion, and that's what we're going to talk about here next. The other thing I mentioned on the premises here, I didn't really make them. This is, remember we talked about all statements can be written as if then. So this is going to be a compound statement. So you got a compound statement. This is just a statement. So premises sometimes are compound statements. Sometimes they're not. Sometimes the conclusion is a compound statement. Sometimes it's not. But anyway, all right. So what we're looking for are, if you will, we're looking for valid arguments. Not all arguments are valid, though. So let's talk about the difference here. So valid argument. You have a valid argument if, when all the premises are true, the conclusion can only be true. If when all premises, some words out. Important words too. If when all premises are true, the conclusion can only be true, that's a valid argument. Think about it, that makes sense, all right? So what we're saying is, we've got two things, and those two things lead me to a valid conclusion. That makes sense. This and this, if these are true, then this can only be true. That's what that basically says. Now, if both of these are true, but the conclusion can be false when those two are true, that's no good, is it? Because we're saying these two must give us this. When these are true, this can only be true. So that's invalid. An invalid argument is an argument so an invalid argument is an argument that when all premises are true, the conclusion can be false. Hopefully that makes fairly good sense there. So we're saying if these two are true, then this one has to be true for a valid argument. It's invalid if these two are true and this one can be false. Seems to make sense, doesn't it? So of course, in our logical arguments, we're looking for a valid argument. Sometimes we come across some invalid arguments as well. Now, one other thing I'd point out is, this is important too, like I said, I left it off originally, but all premises are true. It doesn't say anything about, well, what if one of the premises is false? Well, if one of the premises is false, then, validity, you can't test validity off of that. And you'll see what I mean here in just a second, but the conclusion can only be true when all premises are true. That's how you get a valid argument. All right, so with that in mind, let's test validity of some arguments here. Now what we're going to start with here is determining validity with the truth table. Now we're going to go to some symbols here to keep it a little compact here. All right, so let's say we got this argument. So premise 1 is P arrow Q. If P, then Q. Premise 2 is just the P statement. And then the conclusion is Q. So if P, then Q, then just the P statement. The conclusion off of that for our argument here is Q. So the question is this a valid argument? Now we'll talk about a couple of different ways, but right now we're going to do this one with the truth table, okay? In a second, we'll talk about another possible way of doing this. All right, so here's how it works. So what you do is you do a truth table, all right? So in this case, I've got just P's and Q's, right? So all I would need is 4 lines, P's and Q's. True, 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 false, false, true, false, false. Now we're going to apply that truth table, if you will, for each premise and in the conclusion. So I'm going to do P arrow Q. Then I'm going to do the premise, second premise P. I'm going to do a separate column for it. And then let's kind of double line, because then we're going to do a third column for our conclusion. Okay? So do a truth table for, and you can do it in the same table here. So truth table for each premise and the conclusion. Okay, so this was fairly straightforward. Put the things in there if you want, but they're in the same order and the same truth value. So true arrow true is true. True arrow false, that's the only one that's false. Or that. False arrow true is true. False arrow false, true. Yeah. The only time if then arrow, however you want to think of it, is false is if it's T arrow F. F arrow F is true. Don't forget that. Then the other two parts are real easy because the second premise is just P, so all I have to do is copy the P column. True, true, false, false. And then the third column is just Q, so I just copy Q column. So that's step 1. outline our steps here. Step 1, do a truth table for premises, each premise and the conclusion. So this is if we're going to use a truth table. These are the steps. All right, here's step 2. Step 2, all right, so back on, we're trying to determine if this is valid or not. So remember, the conditional part of validity is we're looking at when all premises are true. If we have a false premise, doesn't matter, okay? So step 2 is mark out any line that has a false premise. Now, it's a false premise. Where are my premises? They're these 2 columns right here. So any line there that has a false premise, I'm going to mark it out. And in this case, we're going to mark out quite a few of them, aren't we? Line 1 doesn't have a false premise because both premises are true. Line 2, however, has a false premise, doesn't it? Mark it out. That means mark out the whole entire line. Line 3 has a false premise. Mark it out. And line 4 has a false premise. The only thing that remains is line 1. So obviously, step 3 is determine it's valid. And here's what it is. It's valid if only true conclusions remain. Invalid if there's a false conclusion. Okay? That's my bad. So, step 3, I'm looking at what's left in the conclusions. Here, the only thing that's left on the conclusions, I had some false conclusions, but I marked them out because of the false premises. The only thing that remains here is a true conclusion. So what do you ascertain by what I just told you there? Is this valid or invalid? It's valid, yeah. Only a true conclusion remains, so this one's valid. If the one that remained had been false, then that means this would be invalid. Okay? So it's pretty simple. Question? Let's do another. So our number 1 here was valid. So it was P arrow Q, P therefore Q. Okay. So number 2. P arrow Q, not P, therefore not Q. So it's a similar one to one we just did, but we've changed up slightly on the premise we changed, second premise we changed, and the conclusion we changed. All right, so let's go into the truth table here. P's, Q's, true, 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 false, false, true, false, false. P arrow Q, column for it. Second premise is not P, so we'll do a column for it. And kind of distinguish it, 2 lines, and then you don't have to do that, but distinguishes it up there. Okay. So P arrow Q, done it multiple times now, so True, false, true, true. Then we're just going to do, in this case, a little more work because we have to do the negation of P, so we got to do false, false, true, true, the second premise. And then the negation of Q is the opposite of the Q problem. So we got false, true, true. So that's step one. Step two, mark out any line that has a false premise. So again, here's my premises. So in step two, I mark out any line that has a false premise. I mark out line one. Yep, got a false premise. Mark it out. Line two. Yep, both of them are false, aren't they? Both of them are false. Okay. And then, what about line 3 and 4? Well, line 3 and 4 got true, true, premise is true, both of them. True, true, both premises are true. So both of those have to stay. So that's step 2. Step 3, is this one valid?
No.
It's not valid, is it? Why? You got a false conclusion left. False conclusion left, so even though one of them's true, there is a false conclusion left. So, this argument is invalid. This one right here is invalid. All right? Question or concern? Let's do one more, and then we'll talk about a nicer way of doing this. All right, so this one's going to be a little different. It's P or Q. Not Q. Therefore P. All right, so let's use a truth table to determine the validity of this argument. So you got P's and Q's, P or Q here. First premise. Then I've got not Q, second premise. And then my conclusion is P. So I got true, 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 false, false, true, false, false. Change it up a little bit because now the first premise is the or statement. P or Q works a little different than if then if P then Q statement. Yeah, so we got true or true here. That's true. But now we got true or false, or true or false is true, isn't it? Or is true if one of them is true. Then we got false or true, that's true. False or false, that's the only time or is false. With me there. Then I've got not Q, so that's opposite of the Q column, so that's false, true, false, true. And then I've got just the P statement, so it's just copy the P. True, true, false, false. That's step 1. So step 2, mark any line out that has a false premise. Here's my premises right here. Anything in the box that has a false premise. So I've got a false premise in line 1. I don't have a false premise in line 2, so it stays. Got a false premise in line 3. And I got a false premise in line 4. So again, marking out 3 of the 4. So step 3 is easy. Is this one valid? Yeah. Yep, this one's valid. Since the only thing left is a true conclusion, this one's valid. So this statement, argument, is valid. Okay?